In this example, we are going to be interpreting correlation. So correlation is a measure of how close the points fit to a line or a curve when we are looking at scatter plots. In this case, we are going to just be looking at the correlation for lines of best fit. We aren't going to focus on curves here. So our goal in this activity is to look for patterns to try to figure out what the correlation R measures. Now notice I've got a lowercase r here. We'll see StatCrunch gives a capital R. You'll see lowercase and capital R interchanged as shorthand for correlation. It does not matter if you use a lowercase r or a capital R. So we are going to label each scatter plot with its correlation coefficient given in the table below the scatter plots. The correlation coefficient is also called the R value. So we're going to look at how the R value relates to the trends that we see in the scatter plot, and then we're going to answer the follow-up questions. So here are our 9 scatter plots, and then the correlation values are given in the table down below. So let's take a look at these. So scatter plot 1 has a correlation of 0.94, and then we notice that the association is positive, and the points look pretty close to a straight line. They're not a perfect fit, but they're much closer to a straight line than some of the scatter plots we saw in previous examples. Scatter plot 2 has a correlation of 1, and so we notice that these points have a positive association, and they exactly fit a line. So we could connect a line that would go through all of these points and have a steady, constant slope. So we are noticing that correlation 1 corresponds with a perfect fit to a positive slope line. Scatter plot 3 has correlation 0.55. So when we look at these points, we notice that they have a slight positive slope, but it's not as close a fit as the points in scatter plot 1 were to a line, and it's definitely not a perfect fit to a line like the points in scatter plot 2. So we notice the positive correlation seems to be associated here with the positive association. If you were going to fit a line through scatter plot 3, even though it wouldn't be an exact fit, it would have a positive slope right through the middle. Okay, scatter plot 4 looks kind of like a big blob. I don't see a positive or a negative association here. If I was going to try to fit a line through the middle, it would probably just end up being a flat line with zero slope. Right through the middle of a flat horizontal line. And scatter plot 4 has correlation really close to 0. So it's slightly positive as 0.01, but I don't think it's far enough away from 0 to make much of a difference. So we'd say scatter plot 4 is looking like there's no correlation here. Scatter plot 5 has a slightly negative trend. If I was going to fit a line through the middle of these points as best I could, I would have a negative slope line or a negative association, and we see the correlation is negative 0.44. So it's negative, but it's not a perfect fit to a line, and so our correlation value is somewhere between 0 and negative 1. Scatterplot 6 also has a negative association. It looks like the points are closer to a line than the points in scatterplot 5. And we notice that the correlation for scatterplot 6 is negative 0.88. So it looks like we're getting closer to negative 1 as our points get closer to a negative line. Scatterplot 7 has a correlation of negative 1, and the points are a perfect fit to a negative slope line. So this is kind of like the opposite of what we saw in scatterplot 2. In scatterplot 2, the points were a perfect fit to a positive slope line, and the correlation was positive 1. Now in scatterplot 7, the points are a perfect fit to a negative slope or negative association line, and the correlation is negative 1. So it seems like a correlation of 1 is an exact fit. For a positive slope or a positive association, we use a correlation of positive 1, and for a negative slope or a negative association, we use a correlation of negative 1. Scatterplot 8, the association seems to be positive, but it's not a perfect fit to a line, so we're expecting a value between 0 and 1, closer to positive 1 than to 0. And we see here the correlation is 0.75. So that matches what we've seen, positive association, but not a perfect fit to a line. And then scatter plot 9 is a negative association, and the points are a perfect fit to a line with negative slope. And so we get correlation -1. So this is confirming what we saw in scatter plot 7. So then question A asks us to identify which scatter plots show a positive association between x and y. So those are scatter plots 1, 2, 3, and scatter plot 8. Which of the scatter plots have a negative association? Those were scatter plots 5, 6, 7, and 9. And then which have no association? That was scatter plot 4, where the correlation was really close to 0. It was 0.01. So now, based on what we've seen, we want to interpret what does the correlation coefficient R tell us about the scatter plot. Correlation measures the direction, and it can be positive or negative, and the strength of the fit of a line or curve to the scatter plot values. So now we want to think about, well, what are the range of the values of R? Well, we only saw values from -1 to 1. We saw -1 was a perfect fit for the negative slope line, and +1 is a correlation where the points are a perfect fit to the positive slope line. So correlation values range from -1 to 1. A correlation R equals 1 is when the points are a perfect fit for a line or curve with a positive slope. That's my little plus there. I didn't have enough room to write out positive, so I use a shorthand. A correlation R is -1 is when the points are a perfect fit for a line with negative slope. And again, I just use shorthand and put in the minus sign to stand in for negative. Definitely okay to use shorthand when you're writing out your math explanations, as long as I can follow your reasoning. How do we interpret correlation 0? A 0 correlation indicates there is no association between the two variables, x and y. I like to think of 0 correlation as kind of corresponding to a big blob, or sometimes if you have a perfectly symmetric curve and you're trying to fit a line, there's no way to fit a line to a curve. So you would have no correlation there because your curve is both decreasing and increasing. And then I put a note here from part C. I said, a value greater than 0 indicates a positive association. As one variable's value increases, so does the value of the other variable. So think about it as x or y goes up, then the other variable y or x also increases. And then a value less than 0 indicates a negative association. As the value of one variable increases, the value of the other variable decreases. So with a negative association, as x increases, y decreases, or vice versa. When we calculate lines of best fit, which we'll be doing in future examples, we also record the correlation because it tells us how good a fit is that line. We will see that correlations that are 0.7 or above, we call those very strong correlations. In fact, if a correlation is anything above 0.4, we actually consider that a strong correlation. So we say in statistics, a correlation between 0.4 to 0.69 is still considered pretty strong. And in fact, we go as low as 0.30 to say that there's a medium correlation. These are kind of approximate values given in most statistic textbooks. You might go interview a statistician or look in a book that has slightly different values, but that's the general range for what we say is, medium is around 0.30 to 0.39 correlation. Strong is 0.40 to 0.69, positive or negative. And then when the correlation is 0.29 or less, we say it's a weak correlation. And then when the correlation is 0 or close to 0, we say there's no correlation. Statisticians use lines of best fit, or we call them regression lines, to model data and make predictions. So the stronger the correlation, the more reliable we expect our prediction to be. We are going to see some examples of matching lines of best fit to data, and then we'll see that there might just be limited ranges of x values where those lines of best fit are good models. But we are going to see the stronger the correlation, the stronger the evidence of the association.